Now we're ready to take a look at radicals and rational exponents. By definition, radicals can be written as rational exponents. The nth root of a is also equal to a to the 1 over n. Remember that a is called our radicand, n is called the index or root, so I want you to pay attention to our formats. On the left side, we have a radical form. On the right side, we have exponential form. And when we write in exponential form, we are using a rational exponent to show our root. So let's practice writing radicals as rational exponents. We'll start with the 7th root of t. So I'm going to write my base t, and then I'll turn the 7th root of t into a rational, which is 1 over 7. When I look at the 4th root of x to the 5th, our base is x to the 5th, and then we're raising this to the exponent of 1/4. As we start to make this more complicated, we get to pull back in all our rules for our exponents. Hopefully you remember the power rule that says when you have a base raised to a power raised to another power, you're going to multiply the exponents. So we can simplify this to x to the 5 over 4. Let's try the opposite direction. This time we have a rational exponent and we want to write it as a radical. X to the 1/5 says the 5 is our root and our radicand is x. When I look at y to the 7/12, 12 is the index, and then I have y to the 7th as my radicand. So notice that the power belongs to that base. Anything in the denominator becomes a root, anything in the exponent is a power. Let's take that a step further and evaluate some numbers. The first one says 16 to the 3/2. So I'm going to rewrite that as the square root of 16 cubed. Now, I want you to see this is the same thing as the square root of 16 and then cubed. So it doesn't matter which of the two exponents you do first. You can first do the root and then do the exponent, or you can do the exponent and then do the root. For this particular one, I'm going to do the square root first because I know the square root of 16 is 4, and then I can cube it to get 64. Now I have 64 to the negative 2/3. So let's think about what all of this means. It means I have the cube root of 64 to the negative 2. We could do the same thing we did last time. We could change this to the cube root of 64 and then later raise it to the negative 2 power. The cube root of 64 is 4, and then let's apply the negative 2 exponent. A negative exponent says we have a fraction of 1 over 4 squared. So our final solution is 1 over 16. As a reminder, when we write the square root, we usually don't include the index, but it's important to think about the index when we switch from the radical to the rational exponent. So we can also write the square root of a as a to the 1/2. So let's simplify a few numbers. If I have 144 to the 1/2, that means I have the square root of 144, which is just a positive 12. Given 125 to the 1/3, I think that's the cube root of 125, which is equal to 5. Let's take a look at x to the 10th to the 1/2. So we know this is equal to the square root of x to the 10th, but I don't want to do that. What I want to do instead is think about my rules for exponents. The power rule says when I have a base raised to an exponent raised to another exponent, I'm going to multiply. So I'd have 10 times a half, which is equal to x to the 5th. I'm going to do the same thing with x to the 12th times y to the 9th raised to the 1/3. This time I'm going to distribute the exponent. So I'm going to have x to the 12th to the 1/3 times y to the 9th to the 1/3. When I multiply 12 times a third, I get x to the 4th. And then I multiply 9 times a third and I get y cubed. So given 49x to the 16th, we may want to say this is the square root of 49 times x to the 16th to the 1/2. Square root of 49 we know is 7, and then x I can see when I multiply 16 times a half I get 8. With the square root of 64 x to the 10th y to the 6th, I can look at the square root of 64 and think about x to the 10th to the 1/2 and y to the 6th to the 1/2. Square root of 64 simplifies to 8. X to the 10th to the 1/2 gives me x to the 5th. And then y to the 6th to the 1/2 gives me 3. As we get larger and larger expressions, remember to simplify as much as you can before you apply the roots or the powers. Given the square root of 36x to the 7th y over 49x cubed y to the 5th, I first notice that I have common factors in the numerator and denominator. 36 and 49 cannot be simplified, but when I look at x to the 7th over x cubed, I know I can simplify that to x to the 4th. We did 7 minus 3 is 4. When I look at y over y to the 5th, the 5 is bigger on the bottom, so when I do 5 minus 1 and get y to the 4th, the y stays on bottom. You could look at that as x to the 7 minus 3, y to the 1 minus 5 becomes x to the 4th, y to the negative 4, and the negative would send the y to the denominator. Now we're ready to apply the radical. The square root of 36 is 6. The square root of 49 is 7. When I think about the x to the 4th and y to the negative 4 being applied the 1/2 power, I think 4 times a half gives me 2, so I have x squared. And then y to the 4 to the 1/2 also gives me a squared, so my solution is 6x squared over 7y squared. As we continue, everything won't reduce exactly like we want it to. Often we'll have remainders, and some things will come out of the radical, and some things will stay inside of the radical, like we did with numbers previously. When I have the cube root of y to the 11th, what I want to think about is multiples of 3. And what I see is y to the 11th could be expressed as y to the 9th times y squared. That way 9 plus 2 is still 11, so I changed the look of the radical, but I didn't change the value of the radical. I can separate this to the cube root of y to the 9th times the cube root of y squared. I only want to have numbers under the radical that are less than the index. So 9 is greater than 3, that says I need to reduce it. 2 is less than 3, which means I get to leave it alone. It's often helpful to rewrite the radical as a rational exponent, so I have y to the 9th to the 1/3 times the cube root of y squared. 9 times 1/3 is 3, so I have y cubed times the cube root of y squared. With the square root of m to the 5th, you may want to write yourself a little note that the index is 2, so I'm going to separate m to the 5th as m to the 4th times m to the 1st power. This allows me to separate this into the square root of m to the 4th times the square root of m to the 1st power. The square root of m to the 4th can be written as m to the 4th to the 1/2, and then I'm going to leave the square root of m. M to the 4th to the 1/2 gives me m squared, and then I keep the square root of m. Again, I'm making sure that my power is less than my index when I write my simplification. Let's try the square root of 28x cubed y to the 8th. So I have 3 factors I want to look at. I want to look at 28, I want to look at x cubed, and I want to look at y to the 8th. I want to look at 28 as 4 times 7, because 4 is a perfect square. With x cubed, I think about x squared times x. And y to the 8th looks really good already, so I'm just going to leave that one alone. As I separate things, I think the square root of 4 is 2, and under the radical, I'm still going to have a 7. When I look at the square root of x squared, I think that's just x, but the x to power 1 stays under the radical. Then y to the 8th, when I take the square root of that, I think 8 times a half is 4, so I have y to the 4th. When I look at the 4th root of 13x to the 6th, y to the 10th, I need to remember to concentrate on that index of 4 to help me in breaking up the factors. I have the 4th root. 13 is prime, I can't break it apart. But when I look at 6, that's x to the 4th times x squared. When I look at y to the 10th, that's y to the 8th times y squared. So I'm breaking it apart by multiples of 4. When I write out the simplification, I'm going to have a part that's under the radical and a part that's outside the radical. Let's go factor by factor. The 13, I can't reduce, so I leave it under the radical. X to the 4th, I think that's really x to the 4th to the 1/4, so that's x. The x squared, I'm going to leave under the radical. Don't forget to put your index in. When I have y to the 8th, I'm thinking y to the 8th to the 1/4. 8 over 4 is 2, so I think y squared. And then I also have a y squared left inside. Let's try the square root of 16x to the 5th over 9y squared. I'm going to go ahead and separate this to the square root of 16x to the 5th over the square root of 9y squared because there's no common factors between the numerator and denominator. The square root of 16 is 4. When I think about dividing 2 into 5, I know that 2 goes into 5 2 times, and I have 1 left over. When I think about the square root of 9, it gives me 3, and the square root of y squared is y. Reducing radicals comes with practice. The more you do it, the better you're going to get.